But first, I actually listened to one of the interviews you made on YouTube, and that was the sentence that you think that 2020 was the year, the most progressive year for Alzheimer's disease research. Like, did it turn out true, and are you satisfied of it?
Yeah. 2020 is when it became very, very clear that if we're going to make drugs, like I am making a drug that stops the amyloid plaque, that this type of drug has to be used 10 or 20 years or more before symptoms. Kind of the same way we treat cholesterol, right? We lower cholesterol with drugs decades before heart disease. We learn we have to do the same. And I think that we saw in 2020 many new drugs that could stop amyloid plaque, but we also had to realize that you have to treat them early. The second thing in 2020 was I started a company with two they were undergraduates at Brown University. So when I met them, one was 20 years old, the other was 21 years old, so not much older than you. And they had an idea about how to protect nerve cells from dying in Alzheimer's. And how nerve cells die in Alzheimer's, what we also learned by 2020 is the plaques cause tangles. The tangles kill the nerve cells, but that's not enough to give you Alzheimer's. You can have lots of plaques and tangles and not have Alzheimer's unless that triggers neuroinflammation. So the plaques and the tangles have to kill a certain amount of nerve cells. That causes neuroinflammation, and neuroinflammation kills 10 times more nerve cells. And so in 2008, I discovered the first Alzheimer's gene for neuroinflammation called CD33. And that gene is now a target for drugs that will stop neuroinflammation. And what happened in 2020 was I worked with these two, 7 years ago, I met these two guys, they were still in college, and we did a project. And we came up with a combination of two drugs that will protect the nerve cells from neuroinflammation. I did not think it would work. And I told them, in science, our job is not to prove anything. Our job is to disprove what we most want to believe. So you come up with a hypothesis that you get excited about, and you let your mind go wild, being excited. And then when you go into the lab, right behind that door, you try to disprove your hypothesis. You show it's wrong. And if it's not wrong, you take the next step. So I said, what we're going to do is take these two drugs. We're going to take, do you know about my Alzheimer's in a dish? Do you know about Alzheimer's in a dish? Where we grow the mini 3D cultures of, we can recreate Alzheimer's in 5 weeks in a dish, right?
Yes.
So we take Alzheimer's in a dish, and I said, we're going to pour hydrogen peroxide onto the nerve cells, and it's going to kill them all. And this is like equivalent to neuroinflammation in the brain times 1,000,000, like 1,000,000 times worse than neuroinflammation. We're going to pour hydrogen peroxide. All the nerve cells will die. Mm-hmm. And we'll ask, how many nerve cells can we save with these two drugs together? I expected 0. But I wanted to teach them this is how you disprove your hypothesis. We did the experiment, and 90% of the nerve cells survived. 90%.
That's wonderful, truly.
Hydrogen peroxide, no drug, all dead. The two drugs together, 90% survival. I said, it's impossible, this can't be right, let's do it again. We did it again, 95%. So we said, okay. So we did a trial in ALS, amyotrophic lateral sclerosis. ALS is also called Lou Gehrig disease. Do you know ALS?
Yes, I've
where the motor neurons die. And Parkinson's, ALS, Huntington's, it's the same. There's different ways to get there, but at the end, it's neuroinflammation that kills the most cells. So if you want drugs that treat all these diseases, you have to either stop neuroinflammation